In this video, we're going to talk about design heating load. This is part 2, and we're going to start looking at the units of that. So go back and watch the other design heating load video, part 1 if you need to, and we're going to pick up where we left off there. Again, I can't stress how important it is that you really get this design heating load problem into your head. You just have to memorize it, and then you'll start to understand it, but you have to memorize it. If I called you up at 3 in the morning and said, "What's design heating load?" you should be able to just spit it out. Just like if I pointed out a dog on the street and you would go, "That's a dog." Well, you didn't always know that. At some point you memorized that that's what a dog looks like. You're going to memorize what this looks like. All right, let's have a look. Remember that design heating load equals QT, heat loss to transmission, plus QA, heat loss associated with air movement, and it has units of BTUs per hour. Okay, so let's look at each one of these factors. Let's look at QT. QT is defined as a thing called U times area times delta T. Now, we've talked about delta T. You know what that is. Area. Area of what? Area of the surfaces of our structure. The area of the walls, the area of the floor, the area of the ceiling. All right, so square footage. So that's going to have units of square feet. Units of square feet, units of degrees Fahrenheit. What is U? Well, U is a measure of the performance value of a material related to how well it conducts heat. So here's 3 different materials. A lower U is better. We're trying to get our design heat load to be as low as we can get it. The least number of BTUs per hour that we have to use to keep our houses comfortable. So here's a piece of cardboard. That might have a U of 1. It's not very good. Here's a piece of insulation, common insulation. It's rigid foam. We'll see that later. It has a U of 0.2. A lot better than that. Here's another kind of insulation. It's got a U of 0.15. It's a different kind of insulation. So it's even better than this. All right, so what are the units of U? Well, if this is feet squared and this is degree Fahrenheit, U has some stuff on the top and some stuff on the bottom. We know this all has to come out to BTUs per hour. All right, so U must have BTUs on top because we know there's no BTUs here, there's no BTUs there. So U must have BTUs on the top. Okay. BTUs, U must have a square foot in there because we get rid of square feet, so there's got to be a square foot to cancel this one out. There's no degrees over here, so this has to disappear. So there must be something over here. And there's no hours here. There's no hours here. But yet we have an hour on the bottom in our final unit. So there must be an hour over here. So those are the units. So let's look here. Feet square, cancel feet square. Degrees, cancel degrees. We're left with BTUs per hour. So let's scratch those out. Again, you can think of these as being over 1. Okay, if you always think of these units as 2 parts. All right, BTUs. So let's see. Feet square, degrees Fahrenheit, BTUs per hour. That is QT. This is how you need to be thinking of these equations. Even if you didn't know what this was, which you probably didn't at the start of this video, you know what area is and you know what delta T is. You could figure out what the units of U were just by doing dimensional analysis. Next, we'll look at QA and we'll do the same thing.